The topic is virtual reality in computer graphics introduction. Virtual reality is one of the most fascinating applications of computer graphics, combining advanced visualization, human interaction, and real-time stimulation. It refers to a computer-generated 3D environment that can be explored and interacted by the user, giving the feeling of being physically present in the environment. Unlike the traditional 2D computer screen, VR offers immersion where the user surrounded by a virtual world. Computer graphics play a central role in creating realistic scenes, rendering lifelike images, stimulating motions, and allowing real-time interaction between the user and the virtual space. Definition: virtual reality is a technology that uses the computer graphics to create and stimulate the three-dimensional environment that can be interacted with the real time using special hardware such as head-mounted displays, gloves, and motion trackers. We are thus advanced form of interactive computer graphics, where user can view, move, and manipulate the virtual object as though they exist in real world. Relationship between VR and computer graphics. Computer graphics is the foundation of the virtual reality. Every element of virtual system, such as the creation of 3D model, realistic rendering, animation, and motion simulation, is based on computer graphics techniques. Some major computer graphics concepts used in VR include 3D modeling to create a digital representation of object and environment, and then to generate a realistic image like lighting, shading, and texture mapping, animation to add life and motion to virtual scene, interaction to respond to user movements or a command instantly, real-time processing to ensure a smooth and continuous visual feedback as the user moves. Without these computer graphics techniques, the virtual world would lack realism, interactive, and immersion. Components of VR system. A complete virtual reality system consists of hardware and software components that work together to generate and control the virtual environment. A hardware component input devices used to capture user action, gestures, and movements. Example: joystick and data gloves, motion sensor, and haptic device. Output device present the virtual environment to user visually and auditory. Examples: head-mounted displays, VR goggles, projectors, surround sound system. Next is tracking device, direct use to position and orientation to adjust the visual accordingly. Example: infrared sensor, cameras, and gyroscopes. Processing unit handles a rendering, animation, and interaction logic in real time. Often includes high performance GPU for fast graphics computation. Next is software components, modeling software used to design 3D object environment and character. Stimulation software manages the physical motion and behavior of visual elements. Rendering it converts a 3D models like to images like lighting, shading, and texturing. Example: Unity and Real Engine. Control and interface software handles use the input and management interaction between the user and virtual environment. Working of VR system. The working of VR system involves several stages. Scene creation. A 3D model of virtual environment is created using computer graphics software. Rendering the graphics engine converts the 3D data into 2D images that are displayed to the user eyes. Tracking and interaction. The system continuously tracks the user movements and head, eyes, and hands, and updates the display to match the new viewpoint. Display and feedback. The proceed visuals are shown through VR headset and sound or tactile feedback is provided to enhance realism. Continuous loop. This process occurs in real time, typically 60 to 120 frames per second to maintain the immersion and prevent motion sickness. Types of virtual reality. Non-immersive VR provides a virtual environment on a regular computer screen. The user interacts using a mouse or keyboard. Example: 3D simulation, CAD software, Semi-immersive VR provides a partial immersion using large screen or projection systems. Example, flight simulator used for pilot training. Fully immersive VR, the most advanced form of VR, uses headsets and motion tracking to provide total immersive. Example, Oculus HTS by augmented reality combines a real-world element with a virtual graphics. Example, AR-based educational tools or games like Pokemon. Applications of VR in computer graphics. Education and training, virtual laboratories and simulation environments allow the students to practice a complex task safely used in the medical engineering and aviation training environment and gaming. One of the most popular uses of VR creating high immersive and interactive 3D games and movies. Architecture and entire design. Architecture used to VR you client virtual walkthrough of a building before construction. Healthcare VR is used for surgery simulation, rehabilitation, and mental health therapy. Military and defense provides a realistic training environment for pilots and soldiers without real world risk. Industrial and product design. Engineers visualize and test product prototypes in virtual environment. Scientific visualization. VR helps to visualize a complex data like molecular structure or astronomical system. Advance of VR enhanced learning helps in skill-based learning through simulation. Realistic visualization provide like life-like views of 3D models, safe and cost-effective training, reduce accidents and resource cost. Better communication allows collaboration and share in visual spaces. Entertainment value provides a new forms of consumer media. Disadvantages of virtual reality: high cost equipment and software are expensive. Healthcare health issues. Prolonged use can be motion sickness, dizziness, and eye strain. Limited physical interaction lacks fully sensor experience like touch and smell. Addiction risk powers may be reduced real world interaction. Technical complexity requires advanced hardware and high processing power. Future trends in VR computer graphics. Inter- Integration with artificial intelligence to create an intelligent responsive environment. Development of metaverse has had 3D virtual universe combining VR and blockchain. Haptic technology stimulating touch, temperature and pressure sensation. Clock-based VR rendering enabling complex stimulation over the internet. Affordable consumer VR device improving accessibility and adoption. Conclusion: VR is a revolutionary advancement in computer graphics that transforms how humans interact with digital content by combining real-time 3D modeling, rendering, and motion tracking. VR offers users an immersive and interactive experience that blurs the boundary between the physical and digital world. From the education and training to entertainment and design, VR continues to redefine the industries and pave the way for the more interactive and visually dynamic future. Thank you.